let's look at some applications. So this is number 72 from 4.5, and we did some of these even on the review and some of the previous lessons, but just to kind of reinforce some of these. So here we have a rectangular swimming pool, and we know the length, right, is 2x minus 1, right? So the length is 2x minus 1, and the width is x plus 2. Okay, so we want a polynomial a of x that represents the area, right? And so remember, area of a rectangle is length times width. Okay, so basically we can just multiply these together, right? So our area function, a of x, right? Remember, this is not a multiplied by x. This is a as a function of x is the way we say this, or just a of x for short. A of x equals the product of 2x minus 1, the length, times x plus 2, which is the width. All right? So whenever you're asked to write a polynomial, make sure you simplify. So I'm going to distribute here by doing our FOIL method. So 2x times x is 2x squared. 2x times 2 is 4x. Negative 1 times x is negative 1x, or just negative x. And negative 1 times 2 is negative 2. So then we're going to combine like terms. So we would get 2x squared, 4x minus x is 3x, and then minus 2 would come down. So this is our polynomial. Okay, and now they're asking us to find a of 5. So once again, remember, this is function notation, so it's not a times 5, it's a as a function of 5. So we're plugging in 5 as our input, right? So wherever there was an x before, now we're just going to put the 5. Okay, so whatever this number is in here, we're going to put that where x was. And now we're just going to operate. So remember, when you're doing this, you just do the right side of the equation. You don't do anything with the left. The left is just a descriptor or a title, and the right side is where we actually operate. So we're going to do exponents first. 5 squared is 25. Okay, now we can multiply, right? So 2 times 25 is 50, 3 times 5 is 15, and then now we can add and subtract. So 50 plus 15 is 65, minus 2 is 63. And then remember, don't forget about units. So we're talking about area, and we're talking about meters, right? So whenever we have area, we're going to have square units. So in this case, since we're dealing with meters, it'll be square meters. If we're talking about perimeter, then we would be using normal meters. Okay. All right. So number 94, area of a parallelogram. I don't know if you've seen the formula for parallelogram. It's actually just base times height, which is another. You can also use that for rectangles, right? So you can say base times height or length times width. So a parallelogram is base times height. So if you have a parallelogram, right, parallelogram is where you have two pairs of parallel sides, right? These two are parallel, these two are parallel. But unlike a rectangle is a parallelogram, but a parallelogram doesn't have 4 equal angles, right? These angles are not all the same. And so in a rectangle, all the angles are equal. They're all 90 degrees in order for them to be equal, right? But here in any parallelogram, this angle and this angle aren't necessarily equal. Okay. All right. But the base is usually this down here, and then the height is that. Okay. So we don't really need to know what the shape looks like, but I just want to give you a little context for that formula. So basically, if they give us the base and they give us the height, we just multiply those together, right? So our area function is going to be 3x plus 2 multiplied by 2x plus 3. Okay, and then it will be very similar to the last problem that we had. Okay, so I'll let you complete that one, but I just wanted to set that one up. I don't think we need to see the whole thing because we've done a lot of FOIL, but I just wanted to show you the setup and the formula for that one. All right, 96. Here we have an area of a square, right? So the area of a square is, we could do base times height or length times width, but our length and our width are the same, so it ends up being the length by the length, right? Or the side by the side. And so side times side is side squared, right? So, right, s times s is s squared. And so that's what we're going to have here is, since our side has a length of 3x plus 1, our formula for a of x is going to be 3x plus 1 squared, right? And remember that all that equals is just 3x plus 1 multiplied by itself. Okay, so we're really just going to be doing some FOIL, and so we would just multiply 3x times 3x and 3x times 1 and 1 times 3x and so forth and so on, right? And so once again, this part I feel like we're good at, and I don't want to take up too much of your time on the video doing stuff that I feel like you know how to do, okay? But leave it in the comments if you want to see more. If you want to see the examples worked out, that's great. If you think it's good that we're, kind of being more efficient with our time and moving on, and you're glad that we're not seeing these, leave that in the comments as well, and then I'll kind of get a gauge of, hey, do you want me to do more of these and finish out these examples, or are you good with the setup with these word problems? Because I think that's really the tricky part with the word problems, is setup, because I feel like you all know what you're doing when we get to that point. Okay. All right, now, and don't forget, with both of these examples, don't forget to plug in the value at the end, okay, and using that function notation. So here our input would be 1. So once we simplify, we're going to plug in 1. Here we're going to plug in 3 for x.